Thanks for clicking. Welcome to another Narculus production. Today, we are going to talk about all the trig derivatives. Not one of the trig derivatives, not two of the trig derivatives, all of six of them. Okay? All six of the trig functions and their derivatives. So we're going to show you where they come from. We're going to show you how they all work and how sine and cosine can get you there. All right? All right, so let's get started. So, right now, we know a couple of trig derivatives. We know the derivative of sine of x is cosine x, and the derivative of cosine x is equal to sine x. But again, what about the other four? We haven't talked about them yet. So, first thing we're going to do is we're going to derive the tangent of x. So, to derive the tangent of x, well, we don't know anything about any of the other trig derivatives other than sine and cosine. So it would be great if I could rewrite tangent somehow with a sine and a cosine in it. But wait a minute. I know how to rewrite tangent. Tangent is just sine of x over cosine x. I learned that back in pre-calc. So now the question is, would I be able to derive sine of x over cosine x? Well, wait. I just learned about that quotient rule. Something with an x over something else with an x. So I can use that to find the derivative of sine of x over cosine x. All right, so let's go ahead and do that. So we're going to use our quotient rule. Remember our quotient rule? OD high minus high D ho over America's favorite snack treat, the ho ho. Okay? Right, if we're deriving that. Okay, here we go. So, leave the cosine. We're going to derive sine of x. We're going to write it out first. Minus leave sine, I d ho, derive cosine over cosine x, and we're going to square it. Okay, here we go. So, we have cosine x. The derivative of sine is cosine minus sine. The derivative of cosine is minus sine x over cosine squared x. Okay, so far so good. I guess that's the derivative of tangent, but now we can clean it up a little. So cosine x times cosine x is cosine squared x. Negative sine times negative sine is positive sine squared x. And hopefully you kind of see where we're headed with this. Over cosine squared x. But wait a minute. In pre-calc, you learned something about sine squared plus cosine squared. Hopefully you remember what it is. Sine squared plus cosine squared is 1. So this is 1 in the numerator over cosine squared. But what's 1 over cosine? 1 over cosine is secant, but it's squared. And that's the derivative of tangent. So the derivative with respect to x of tangent is the secant squared. That's the correct answer. That's where it comes from. It's not magic. Okay, I don't have a magic wand here showing you, making magically these things appear. They all come from somewhere. All right, there's your derivative for tangent. So let's also find the derivative for cosecant. Okay, we'll find the derivative of cosecant. We'll find the derivative of cosecant. Cosecant. Well, same idea. Cosecant is 1 over sine. Now, I wouldn't normally use the quotient rule on 1 over sine x, but we could. It's not wrong. Normally, we don't need it because there's nothing in terms of an x up top here. But for right now, I actually can't take sine of x, bring it to the top, and derive it because that involves another rule called the chain rule. You don't quite know that yet. So we're going to use the quotient rule on this. It's going to be OD high minus ID ho over America's favorite snack treat. Ho ho. Okay, here we go. We have sine of x. The derivative of 1 is 0. That's a number. Minus 1. The derivative of sine is cosine. all over sine squared x. So sine x times 0, that literally just washes out. It doesn't even exist anymore. It's gone. So that gives me negative cosine x over sine squared x. Okay, so now we can simplify this a little bit. And we're going to take the sine squared x that's on the bottom, and we're going to split it apart into sine times sine. Okay, nothing wrong with that. I'm just rewriting it separately multiplied. Leave the negative there. Now, I'm going to take the cosine and the sine, put them one over another, and then write 1 over sine x as well. So now I have cosine x over sine x times 1 over sine x. Still the same thing as this one up here, just rewrote it. So now cosine over sine, that's cotan, and 1 over sine is cosecant. So normally the way we see this is like this. The derivative of cosecant x is minus cosecant x cotangent x. We normally see them in the opposite order, but that's the rule. That is the derivative of cosecant x. Okay, so now here are all 6 trig derivatives. Now, a couple of these I didn't show you, right? I didn't show you cotan, I didn't show you secant. There's a reason for that, and I'll show you in just a second. So the derivative of sine x is cosine x is minus sine. Derivative of tangent is secant squared. We did that one. The derivative of cotangent is minus cosecant squared. You can get this answer by doing the same thing we did for tangent, except you derive cosine x over sine x instead, because cotan is cosine over sine, and use the quotient rule. Secant, well, we did cosecant. To do secant, you do the same way you did cosecant, except you write 1 over cosine and derive that. So it's basically the same exact thing, done again using just a different trig function. Same process, everything goes through the same way. Okay, and derivative of cosecant x is minus cosecant x times cotangent x. All right, so let's take a minute here. We'll try one just to make sure you got the idea. F of x is 3x squared times secant x. Find f prime of x. This is a product rule problem. Remember your product rule. Okay, we're going to derive f of x. So we're going to leave the first, 3x squared. We're going to derive the second, plus leave the second, and derive the first. So leave the 3x squared. The derivative of secant x, we just did it. You do not have to prove it or justify it again. You can literally use the rule. The derivative of secant x is secant x times tangent x. Plus leave the secant x. The derivative of 3x squared is 6x. And now if you wanted to, you could factor out. There is a GCF. There's a 3x and a secant x all in common, which would leave me with x tan x plus 2, and yeah, that's it, just 2 over there. And this would be an answer. This would be a good answer. This is also a good answer, depending on the situation that you're in. And that's it. So we're literally just using these rules that we see on this page. Okay, you're not showing me that the derivative of cotan x is negative cosecant squared x like I did for tangent. Once I've showed you the rule, you can just use the rule. The derivative of tangent x is secant squared. But if you ever forget that the derivative of tangent x is secant squared, you can derive sine x over cosine x, and you should eventually be able to get to secant squared. All right? And that's it. Okay? Those are all 6 of your trig rules. Okay? And as always, thanks for clicking.